Hello, 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 everybody. Happy Thursday. Hope you're doing all right. Let me down a little here, and maybe we'll just turn it off. Probably don't need music in the background. All right. So, couple things here. Let's do a quick little checkup on where we are while I grab some coffee. Hey, Bay, how you doing today? All right, so we're going to talk about lists and dictionaries. We got through all the lists. We're going to talk about dictionaries. And then next week we've got classes, exceptions, modules, files, Thanksgiving break. So the goal here, because we had to move a couple things around with our schedule, is that I can talk about the final project on 11/11. So we're going to talk about the third individual project today. That'll be due in 2 weeks, then on 11/11. And then on 11/11, I can't say that often enough, 11/11, we'll talk about the final course project here, which will be due when we present our projects here. So it'll give us 3 projects for our project score. It'll give us our final project for that score. I'm working on your midterms. I'll get that done this week. We got our weekly labs we're doing. We got the weekly quizzes, and then the Zybooks. And that ought to make up all of the points for the course. Yeah, we can do those. I skipped them on Tuesday because no one was interested, but if you want to see them for sure, you can do that, no problem. So actually, let me, I think I've got the midterm review project. Let me just open that up, right? I'll just throw them in the midterm review. Does that sound okay? Let me grab that. Let's do that. Midterm. And preview. All right, you said just the long answer ones, right? Like prime, factorial, plus, odd, minus, evens. Again, just coming up with some, trying to make something you can't Google was a sort of idea. Okay, yeah, no problem, babe. You can do that. So again, I said, hey, if you want to use the prime method or function that we had, go for it. And I linked right out to where we already had that here, actually, is prime. We can use that right away in our function. We'll define a function. So it's prime factorial plus odds minus evens, right? Given a number. I think that's what we had, right? Plus odds minus evens, right? So starting with 1, and for each number from 2 to n, if the number is prime, multiply it. If it's odd, add it. If it's even, subtract. So it's kind of just a screwy thing here. So I said start with 1, right? Because we're adding odds. So 1 is odd. So we would start with 1, right? So really then in our loop, then we have a result that starts at 1. And then for n in range, I'm going to go number plus 1 because we want to include the number. Right? If we're including our number, where to go here? Result, so number is prime. Oh, maybe I didn't actually say include the number. So either way, I guess it's 5 then. I sort of assumed you would get to n, but I guess that's not completely clear there, that we would include n. But if you're ranging then, and you want to include it, you got to go plus 1. Right? Or maybe we'll say value. I don't know. Sure. Why not? How about value? Now we want to check if it's prime. So if is prime of the value, then we're going to take a result times equals the value. Now if the value mod 2 is 1, we're going to take our result plus equal the value. And if it's not prime and it's not odd, then it must be even. We can say result minus equals the value. And we're done, we can return the result. Let me zoom that in a little bit, sorry. Right, a little easier to see. So we got 3 cases. If it's prime, multiply. If it's odd, add. And if it's not odd, it must be even. Let's subtract. Right, for our prime factorial plus odd minus evens. Number prime, multiply it. If it's odd, add it. If it's even, subtract it. Okay, next one, function a bad hash of some string that returns the sum of all the character ordinal values, and then a verify bad hash given a some string and some hash value. Returns true if the bad hash of some string equals some hash value. Otherwise, false. Okay, so we got to do bad hash first. Bad hash given some word. I don't know. What do we? I say some string. Sure, we'll call it some string. Given some string. So we want for each character, so for character in some string, right? For each character one at a time. There's a quick way to loop through our string. We need the ordinal value, so we need to have a total here then. Right? I guess we can call it even our hash. Starts at 0, and then we'll take our hash plus equals the ordinal value of the character. When we're done, we return the hash value. Okay, it's upset we've used the word hash, but we should be fine here. And that's all bad hash does, right? Just add up the ordinal values. Again, that's not a great way to hash things, but it's a bad hash, okay? Sum of all the character ordinal values. And then a verify bad hash given some string and some bad hash, right? So we're going to return some bad hash equals bad hash of some string, right? If they match, we return true. If they don't match, we return false, right? This is just a quick little comparison here. And you could have done it in more than one line. Nothing wrong with that. But, you know, again, nice and easy to do it all on one line. What you don't want to do, because it's obnoxious or, you know, extra typing they don't need to do, you don't want to say, if this is true, return true, true, else return false, right? Don't do this, because this is already true or false, and if you're saying if something's true, return true, otherwise return false, you can just return that thing, right? Save yourself the trouble of typing and just return that thing, because it already is a true or false value. Hey, Trumpet, no problem. How you doing today? We're going over the midterm questions real quick. Yeah, oh, there's not a colon there. There's a particular route that if I take, I can get stopped by the exact same train 3 times in a row. If I take this particular path when I'm heading into Novi, it is so annoying. So usually I'll just hit it once, but if I'm trying to like take some of the side roads to get somewhere instead of the main roads, I can hit it 3 times. Awesome. Right, so that's bad hash and verify bad hash. And our last one here is a vowel count sometimes y. Given some word, returns a count of all vowels in some word string. And because y is sometimes a vowel, generate a random value 1 to 10 every time there's a y. If the value is odd, count y as a vowel. Be sure to account for upper and lowercase letters. Okay, so it's a count of vowels sometimes y given some string. Right, and we're going to do this for character in some string. That's the first time you've seen a train on this train. Wow. That's interesting. So if we need to check for if it's a vowel, right, I guess we need a vowel count, right? So we'll have a vowel count. Starts off at 0, sure. And then a couple ways of doing this, right? I'm fond of this way. I'm going to say vowels is equal to a list or a tuple, right? Either one's okay, of A, E, I, O, and U, right? And then we can say if character dot, lower, to lower, character dot lower, oh my goodness, dot lower, to lower, oh man. What is the to lowercase? Why am I not remembering it right now? That's all right, we can Google things. Python string to lower. Yeah, lower. It's just a function lower. Not lower. Okay, why was I not it wasn't doing it? Character dot lower is in vowels. Right? I'm fond of doing it this way, right? Because that way we can just check the vowels really easily instead of if, else if, else if, else if, else if. Well, there's nothing wrong with a bunch of those either. Take our vowel count plus equal 1. Else if the character dot lower equals a y, then we need to do the sometimes thing, right? So random dot randint 1 to 10. We got to import random. Let's import random. Import this name. Import random. Did I do it? Import random. There we go. So then if my random randint 10 mod 2 equals 1, right? If it's an odd, we'll take our vowel count plus equal 1. Right? And really, you could even combine this here. We could do this and this thing here. Right? Kind of save yourself one line here. Nothing, nothing wrong with doing a nested, but it's the exact same thing, right? So we're just kind of combining it here. We're saying, okay, here's that. And then when we're done, we'll return the vowel count. Now, the funny thing with this is because it's using random numbers, it's not going to be very repeatable, right? If I give it some sort of value here, it's not going to give me the exact same result every time because it's random, which is good. Right? We want it to be random. That's sort of the goal. I guess if we gave it something that's not, or that didn't have any y's, it'd be easy enough then, right? But we want to make sure it does count our y's occasionally, right? So we can try it here, right? We can print vowel count of vowel, sometimes y of like y. Nothing wrong with just an if either, because it can't be both, right? What happens behind the scenes, Bay, is that it actually would evaluate both then if you don't have the elif. So if it was an A, E, I, O, or U, then it would also check if it's a Y, which like essentially is wasting a little bit of computer time, because if it is one of these, it can't be this. So the elif performs ever so slightly faster. Again, we're not doing like millions of checks or anything, so we're not going to notice the difference, but it's a good habit to get into that if you don't need to evaluate this next thing, right? We might as well put it with an else. Yeah, but it would functionally be the same to just have the if there. Yep. We just get a slight speed increase. So we should get a couple vowel counts here with y, right? We should get a couple odd numbers, but it's probably going to be different every time. So I got 6, and I run it again. I got 6, run it again. Now I got a 4, right? Now I got a 6, got a 5, got a 6, right? So we're getting different values each time. This was kind of what we expected, right? That makes sense for those long answer questions? Again, hopefully no big surprises there. Pretty similar to what we had in the practice, right? Just trying to mix it up just a little bit here. But looping through strings, doing things with those ordinal values, right? We did that with this bad encryption, using the ordinal values of things. Checking if something's in it, that sort of thing. Oh yeah, so actually we wouldn't even need, right, to make it a list. We could just say A, E, I, O, and U as a string, right? Because you can also use if there's a character in a string. That'd be even faster than checking if it's in a list. I like that. That's even better, right? Because you can do a substring if there's a character in another string here, right? If it's in vowels. Just making sure you're doing the lowercase, or you could then, if you want to just, put in all the uppercase ones. Got lots of options. No wrong way, for sure. No wrong way. All right, we go with that. Let me commit that to GitHub then. And then we'll come back and we'll start picking up the dictionary stuff. You have 4K bytes. Oh, I added a new reward there for bytes. You make me do silly things here. So here's Midterm Solutions. I got a cool deck of cards. No, not cards, a cool deck. From the local gift shop of knock-knock jokes. And there's 100 knock-knock jokes in here. So if you're interested, you can redeem a knock-knock joke instead of a dad joke. And I will pull one of these cards and read a knock-knock joke to you. It's just a way to break up the monotony, because, sitting here and listening for an hour, it's hard. It's really hard. So, all right, let's see. I read that, or I did that one already. Let me go. I guess I should try and shuffle these a little bit or something here. Put those ones in the back. All right, here we go. Knock, knock. You say, who's there? Say, egg. You say, egg who? Said, excited to see me? All right, shots. This one's for you. Knock, knock. Who's there? Carl. Carl who? Carl will get you there quicker than if you walk. All right, we might have to say that one with an accent. Knock, knock. Who's there? Europe. Europe who? No, I'm not. All right, one last one. I saw this one and I have to read it to you because why not? Knock, knock. Who's there? Britney Spears. Britney Spears who? Knock, knock. Oops, I did it again. Oh, that was a quality knock, knock joke there. So I'll have those handy in case you need more terrible jokes. Okay, the last one. Yeah, the last one was pretty decent, right? That was pretty decent. Let's do our lists and dictionaries here. And I got to pull up. We're not missing anything here in our Zybooks. We had all sorts of fun with lists. We did our tic-tac-toe game, which was lots of fun. So you can find our dictionaries here now. I'll probably do this up at the top, right? Because otherwise you have to run through all the other stuff. And we ended up playing tic-tac-toe a bunch of times because I was too lazy to move that or comment it out or something. Boop, 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 boop. Okay, we'll zoom this in a little bit more. All right, we got pretty far. We did pretty good on Tuesday. All right, so we know, again, the dictionary is the mapping type. We get a key and an associated value. That's the idea with our dictionaries. Key and associated value. So a couple ways of making dictionaries, right? Generally, we do the curly braces. So like my dictionary equals with a set of curly braces, we have some key, colon, some value, right? Some key, some value, and then we comma separate. Key, some value, right? And remember, oops, colon here, colon, there we go. The keys need to be unique. The values do not. So some value can repeat here, but the keys need to be unique, right? And then we work with dictionaries. We say my dictionary. We use the square braces. Oh, I'm going to spit all over you here. It's a good thing we're not in person. We use the square braces to say key of. So I can say, hey, give me the value associated with some key. I would get some value back out, right? So you read this as key of instead of index of when you're dealing with dictionaries. Excuse me. The other way you can make a dictionary if you want, but again, it's kind of funny, you can use this Dict constructor here, and then we can now have in here a key equals value. And I hate that it changes the variation. I don't know why here. But you can do some funny things with these. So if you don't like your quotes, I can say some key equals, and then in quotes, some value, comma, next key equals some value. Right? You can do it that way, and this is the key equals the associated value. And then should save this somewhere. So my other dictionary equals a dictionary. So create the dictionary of this, right? There it goes. That red line went away. Now, if you don't like that format, you can give it in a different format, which this one is the worst, I think. So this is my ugly dictionary. Equals a dictionary, right? Using this creation. Now we give it a list of tuples. And in the tuple, we give it a key and a value. So we have some key, comma, some value, comma, next tuple. Next key, comma, next value, in quotes, next value. These things are terrible, right? I am not fond of either of these ways. Just use your curly braces. They're much easier, right? Like, why bother? So, I don't know. It's ugly. Now, to remove a key in a dictionary, right? We can take my dictionary, or my ugly dictionary. We have a, what is it? Pop. You can pop a key off. If you don't like to pop, right, let's pop next key off of my ugly dictionary. Sorry, in quotes here, because that is a string. We can print my ugly dictionary. We'll print my other dictionary. just to show you that they all look the same here. And we'll print my dictionary. No benefit that I know of. No, not really sure. There's just always more than one way to do things. So like you want to know that they exist, so when you see it, you're not super confused by it like I am. Right? We all get the exact same dictionary out of each one of those creations. They're just other formats is all here. But so to remove something, you can pop it, right? Or you can use the del for delete here, and you can say my ugly dictionary, key of some key. And I'm not fond of this delete keyword either. The syntax just seems really weird and funky. Usually, like, we're used to this pop notation when we deal with lists and dictionaries. So pop is, I think, much more conventional. But now, right, we can print it. Oh, did it not delete it? I don't think we printed it enough. We printed it. We popped next key. It was gone. Oh, there it is. Yep. Okay, I'm sorry. There was empty. There was the empty dictionary from that print here. Yep, I just missed that one. So when we remove next key, and then so either way you want to delete, right? Either way is fine. Great. Now remember, this is the set and the get, right? Set or get. You can either get the value out, or you can set the value by assigning to this here. Either direction here. So you can set it to a new associated value, or you can just get the associated value back out. Now when we loop through dictionaries, right, we can say for, we'll call it a key in my dictionary. We can print the key, and then we can print the my dictionary key of key. Right, so you get the key and the associated value. So I'm going to add a little like colon here for fun. Right, when we print this out, stop and run. Actually, stop it. There it goes. So we see key, associated value, key, associated value. So when you do a for loop, you get keys here. You can test for keys. You can say if some key is in my dictionary. Now, a lot of you actually got this wrong in the quiz that we had way back when we talked about types and we looked at dictionaries. The in operator only works for keys. It does not work for values. Right? It only checks for keys, not values. Checks keys, not values. Print, we'll say found some key in my dictionary. Sure, that one's not very exciting, but we can do that if we wanted. Right, and we say, hey, we found some key in my dictionary. We can see that it's in there, right? So we can check to see if it contains an item. Right, other cool things you can do. Now, if we just try and get that particular value out, so we could say, hey, we just want to print my dictionary key of, oh goodness, key of, stop with all the enters. There we go. Some key, right? We can do that, and then we can print another key, right, like this, and let's give it a run. We actually got to stop it here. And now we get, ooh, it crashes. Key error, another key. Remember, we're case sensitive here, and mine is called next key. Oops, so I don't even have another key. I just have next key. So it crashes real hard here. So a great way that you can do these lookups, right, if you're too lazy to say, hey, if, another key is in my dictionary, you can use a dictionary method here, and you can say my dictionary.get. You can get the value associated with another key. Or what do we call it? Yeah, I think it was next key, right? So if you call get here, we run this, it doesn't crash on me. I get a none value back out. So get will avoid crashing. You get a none back if it doesn't exist. And the other cool thing, you can give it a default value. You can say, okay, if it doesn't exist, give me, instead of none, maybe I want like NA or something, right? You can do all sorts of cool optional defaults here, which is fun, or an optional default. So get's really handy if you're not sure if the item exists. Like you can try it and you get a default back out. When you use pop, it does return the value associated with that key, right, where delete does not. So pop, you can get the value out as you're removing it if you want. So like you can actually print the result of a pop and you'll get the associated value. That one's kind of fun. So a couple ways we can iterate or loop over dictionaries, right? The for key in dictionaries are common way. Right? This gets me each individual key out at a time. But what we can also do is we can get a couple other options. So we can say we'll say item in my dictionary dot items. I'm sorry, dot values. Dot values gives you the values out. This is the associated value. Now the problem with doing this is we have no idea what key it came with. So this is not all that useful. Like we could print the associated value, but we don't know what key it belonged to. No, I think you'd have to do the get. Because if you'd say if my dictionary key of another key equals none, print none. Don't think that's going to work. Because as soon as we do this lookup, it's going to crash on us. Yep, we get that key error. So as soon as you try a lookup, it's going to fail. So you got to use the get. But we already have this in operator, right? You can like already check in without having to do anything other special, anything like that. Yeah, so getting the values out is not all that useful. More useful though is we could say for key comma value in my dictionary dot items. So items gives you key value pairs. Print key value. Now this is exactly what we did up here, right? But we don't have to type this key, my dictionary key of key out, right? We just can get it out here. So it's just another way of looping over the dictionary here. That's all it doesn't. That's all it really does for us here. Oops, it's going to crash again. We should not do that. And run it again. Okay, so just another way to get your keys and values out, but it will do that unpacking for you. So it gives you key value pairs out. So that was pretty common of looping through here. So when you get the values out, they're not in any particular order. A dictionary doesn't maintain order. So if you want a sorted order, remember we can sort lists. We have a way to do sorted lists, right? There's a sort method here. We could get all the keys out here. So we could say for key in my dictionary dot item dot keys, and we need to do a sorted one of these. Right, sorted will give you a new value back and print the key colon my dictionary of the key here. Stop and run. Right, so you can guarantee you get a sorted order here by sorting the list of keys. Right, we can get those out. It's just an option here. Technically, what you get here is not a list. It's a view, which is technically different than a list. So if you want it as a list, you can use the list constructor. You can say, hey, I want this as a list. Right, like this, you can say list of items here. So once you have a list, then you can go through like the range length of an index or something. If you don't turn it into a list, you actually can't get at them by index is all. Because it's not really a list, but it's not all that common, but sometimes you might see people doing that. All right, and just like we can put a list inside of a list, you can put a dictionary inside of a dictionary, which is kind of fun. You can do some interesting stuff with it. Again, we'll see some better tools and better ways of doing that. We move on to classes, but a dictionary of dictionaries, it's doable and possible and sort of makes some conceptual sense. So if I were to say, hey, I want a grade book, and we'll make that a dictionary, then what I can do is I can add by name could be your key, and the associated value could be another dictionary of assignments and scores. Right? We could have some sort of way of, okay, here's my list of students. That's the initial key in the gradebook, and the associated value is another dictionary of all of your assignments and their scores. Right? We could have a dictionary of dictionaries. Right? So we could send gradebook key of Eric equals a new dictionary, right? And then inside of that dictionary then, so then gradebook key of Eric gets me the associated value, then key of, quiz 1, right, equals 10 or something like this. So we could go on through and give me a couple different quiz 2, quiz 3, on and on and on, and then, I don't know, maybe project 1, right? We could start assigning things like that. And we could have other students. We could add other students and add all of these here. So you can have a dictionary of dictionaries. It gets to be a little confusing, but like we can loop through each key in the gradebook and then get each associated dictionary out and get all of their keys and values back out. Excuse me. So we can add another student here. Right, let's add my wife. She wants to take classes with us, right? So we'll add Jasmine. And then we'll add her scores here. So then if I just print gradebook, it's going to be a little funky, but it should print out. Actually, stop it. There we go. We see here's the first item, right? That's Eric. The associated value is another dictionary here. This entire associated dictionary. Then here's the next key, and its associated value is another entire dictionary here. So if I wanted to just get my scores, right, I could say for, I don't know, what do we want to call this, like assignment, I don't know, or grade item in my grade book, key of Eric, print the grade item, and a colon, and then the score would be gradebook, I'm sorry, the grade, nope, yeah, for each item in that dictionary, the associated value, yep, so we need the value. I don't have the name of the dictionary, so it's this one, key of the grade item here. Right, so we should see, okay, here's, for me, here's all my scores for each project, right, and the name of the projects. Right, so quiz 1, I got a 10, quiz 2, I got a 10, quiz 3, I got a 10, project 1, I got a 10. Right, so again, two-dimensional dictionaries, they do sort of start to hurt your head. It can be a little funky here, but, at that level, it can sort of make sense here. Right, you can sort of see how those work. Why is there a string formatting chapter in here? Something got messed up with our Zybook. I'm sorry. That's super weird. Don't know why that's in here. It should have been in our strings chapter. Give me a sec. I can fix that. I'm sorry. That shouldn't be in there. In 1 second. That section should have been... Need to edit this. Give me 1 second. I need to edit. Where's my edit button? Configure. There we go. I think maybe I dragged it in the wrong place. Is that my mistake? I want the string formatting to be in the string chapter. That's super silly. I mean, the old formatting is still very common. People still use it with that %sign. So it's good to see. Let's look at the string formatting up a little more. Come on. There we go. Okay, so I moved that into the string chapter. That's fun like that. Save and exit. Sure. Okay. All right, now we cleaned that up. So there might be a little extra section there in the string chapter. Sorry about that. But it was in this chapter, so that's all. Oh, that's probably why, because you can have a dictionary using the string formatting. That's why they had it there. That's silly. Mapping keys. Yeah, that's sure. That's fine. All right, no big deal there. All right, so I think that gets us through dictionaries. We're in pretty good shape there. How's that? Does that feel okay? Not too bad? What do you think? Awesome. Cool. Yeah, I mean, we've done some with dictionaries before, so this was just a little bit of a deeper dive on dictionaries here. String formatting using dictionaries. Sure, okay. Why not? All right, so let's talk about our last individual project then. Again, the goal, the final project, I'd like you to work in pairs, but given we're still in the middle of a global pandemic, it's if you prefer to work individually, that's perfectly fine. If you'd like to do it in pairs, that's great too. So we got options there. And then we will have our lab on Monday on lists and dictionaries as well. All right, so let's do project 3. So that puts us out in 2 weeks then, right? So on 11/11, 3:30 p.m. So we can cover it at the start of class here. And I think this will probably be worth 20 points here. They increase in points because you don't get to forget any of the things you've done before. Right? None of it gets to go away as we learn new tools and techniques. New ways of solving problems here. So you need a URL. Come on, Canvas, load for me here. Online, website URL, fantastic. We need the GitHub Classroom thing. Let me give you another template here. Python template. Here we go. Feedback pull request. All right, there we go. The URL to your feedback pull request. All right. So what we're going to do here is we're going to kind of take that idea of that tic-tac-toe game and expand on it here. Are you folks familiar with Connect 4? Connect 4 game? It's a lot of fun. So this one I don't think is a solved game. Right? I don't think there's like a one... Wait, maybe it is. I don't actually know if it's solved or not. Maybe I should Google that. Is Connect 4 a solved game? Oh yeah, okay. So I guess it is. The first player has a winning strategy that lets you always win. There we go. Back in 1988, they figured that out. Nice. If you play perfectly, you can always win. Good to know. Good to know. Man, that would drive my kids nuts if I could always beat them at that. That's unfortunate, though, but that's okay. So we're going to build a Connect 4 game that allows to play Connect 4. So similar to the tic-tac-toe game we created. Alternate turns between players, and then which column I want to drop a piece in. Now with this one, right, with Connect 4, right, you don't say, hey, here's my particular grid location. Right, you just say, hey, this is the column I'm dropping it in, and we need to drop the piece into the lowest possible option. Right, so if you imagine this was our grid here, let me just show like an image here. You do an image here, right? Let's do that. One that's not all diagonal. Okay, this one here. This one looks like it'll work. Here. So, can I do my screenshot? This isn't going to blow up the stream, is it? I think I can screenshot things still. Let's see if that works. Did that work, or did that freak out the stream? I haven't usually actually used the snip tool. Right? When we look at two-dimensional lists, right, this is index 0, this is index 1, 2, 3, 4, and 5. It's a 4, that 5 you can't see because it's red there. Let's change that to black. 5, right? And then you get columns 0, 1, 2, 3, 4, 5, and 6. So you're going to ask them what column do you want to drop your piece in, and then you need to go find the last available open slot Or if it's completely full, right? If we had another piece here, we had another piece here, you have to tell them, no, you can't put a piece there. Right? So we have to do some bit of validating here and making sure we find the correct column in which to drop it in. That make sense? And again, checking for if someone won is a little trickier. There's a little bit more to it here, right? To see whether or not you get a 4 in a row, right? You need to get 4 in a row, which could be those 4, or it could be these 4, or it could be these 4, or it could be these 4. For 4 in a row that way. For 4 in a row vertically, right, it could be these 4, or these 4, or these 4. Right, so there's 3 verticals and there's 4 horizontals, 4 in a rows. And then the diagonals are also a little bit tricky, right? So starting in each column, right, you can do diagonal up. So I can have these 4, or I can have these 4, or I can have these 4. So there's 3 diagonal ups in each starting column, only for the first 4 columns though, right? Because you need the last column you can start in for a diagonal win is right here to get 4 in a row. So you can't have a diagonal win past column 3, right? And you can't have a diagonal down win, right, below row 2, right, going this direction here. So there's some limits around what we need to actually search for, right, to find some of these. And you can do some loops to make this easier, right? Loops and indexes will make life a lot easier here using it as 2-dimensional list. Okay? So that's the idea here with our 2-dimensional connect for. Oh, where'd it go? Where'd it go? Where's Canvas? There it is. So the game ends when player gets a 4 in a row, horizontally, vertically, or diagonally, up or down, right? Or if no more pieces can be played, right? Does that part make sense? So we're gonna ask them, hey, what column do you want to drop in? Right? They can drop a piece, so we need to print out the board. So we're going to print the board each time. Ask a player to go. Right? X's and O's is probably easiest here, rather than like red and yellow. There's ways to do the cool color formatting stuff, but again, that's not, our purpose isn't really pretty. Here it's functional. Okay? That's sort of the goal, to make it functional, not necessarily pretty. All right, so let's see here. So the board should be a 2-dimensional list, right, of essentially characters, right? Open, X, or O, I guess, right? You can have X's and O's. I think that should be fine, or just open, X or O. Right. Is that helpful to say that one's open? Open space. X or O? Sure. Okay. How's this one sound? It's gonna be a lot, right? There's a lot to it here, but similar to what we did with our tic-tac-toe approach, right? Take a big problem and break it down into a smaller and smaller and smaller problem. You can essentially do a very similar loop here, right? As long as the game's not over, right? Keep on going, keep on going, keep on going, keep on going, keep on flipping the turn here. There's a lot of repeating stuff here, but to figure out, right, if the game is over, right? Is it a cat's game, or did the player win? The players, right? You win by row, you win by column, you win by diagonal. You can have a diagonal up, you can have a diagonal down, right? Cat's game, it's essentially the same thing here, right? For if it's a tie, right? If nobody won, then sure. Right? So that's what we're going to do for our last individual project. Okay, so we'll have 2 weeks to work on that one. You're welcome to work on it during lab time as well. Right? Bring questions to lab is a great time to ask me questions. If not, I'm always open to meet by appointment. The scheduling is a little bit funny here, I'm sure, for everybody. So if there's propose a couple times that work for you, and I'll see if I can make it fit in my schedule. We can definitely meet and chat about it if you feel like you're getting stuck somewhere. But definitely, I think this will be doable, and hopefully it'll be, ever so slightly fun by the time you get to the end of it. You can actually play Connect 4. We're not making the computer play. We're not doing the solving portion of it here. Right? That's more advanced stuff you could do later, which is really cool and interesting. But for now, it's just, keep asking the person which column, which column, which column, which column, right? And just whoever's sitting at the seat gets to pick, right? Multi-online play, all that sort of stuff is what you can do at another point in time. That sound okay? So we do need a rubric for this one, though, right? So let's do... My goodness, I gotta save it first, and then I can add my rubric, right? There we go, add the rubric. Add a rubric. This is project 3. Add some more criteria here. Oh, I can edit this one first. Okay, so board is stored as a 2-dimensional list of characters. Sure, you can have a couple points just for doing that. Oh, I can change the rating here. There we go, 2 points for that. The user, which column, drop in, validate, it's a valid column, and there is a space to drop the piece. Then to a different column. So if they enter an invalid column, or if they enter a space, right, that already has a piece in it here, let them pick again, right? Don't skip their turn. So that's an important piece here. We're not going to skip their turn there. So we have game ends when tie or someone wins. Right? 5 points for them. Let's make these worth a little bit more here, right? Sure. And so it's stored. Board is printed before every turn. Right? Just spit out the board. Make it look nice, right? So they can see what's on the board. Right? We should print it here. We'll return, include the column labels. So when you do your printing, include that column label, like, hey, this is column 0, this is column 1, this is column 2, column 3, as like a little helper for them so that they know to which one to pick, right? Because just looking at some output on the screen here can be really awkward if you're like, hey, where do you want it to go? Right? So like for us, hey, I can count it, I can kind of visualize it here, but we're going to include that little helper bit for them, right? So, okay, we say this one's 0, this one's 1, this one's 2, right? Either above or below, whichever you prefer, and make that the helper bit there be nice here. Prompt them for which columns are up in, validate it, or let them pick again. That should be fine. Game ends if there's a tie if someone wins. And actually, there's not even a whole lot to connect for, is there? Maybe we should make that worth some more points then, right? Should that be worth like 10 points for that one then? Right, that's essentially the game, right? That sound okay? That'll be our 20 points for the rubric. That one get attached. Project 3. It didn't attach the rubric. Find a rubric. Okay, that looked funny. What is going on here? Oh, I want my rubric. Where? This one? No, this one. We're a 1501. I know what this is here. There we go. Use this rubric. That was super weird. I'm sorry. Like it took me to another page. Cool. So we got the rubric here. 20 points. So if you didn't do quite as well in some of those earlier projects, this 20.1 will make up for that as well as we go. All right. Any other questions, thoughts, concerns? How you folks feeling? Cool. Yeah, sounds good. All right, awesome. We'll wrap this up then. We'll send a raid over to somebody else for funsies out in Twitch land. Let's see who's around. Yeah, definitely doable. And the goal is everyone gets it done, right? I'm seriously happy if everyone gets 100% on their projects. honestly, I don't understand when people don't finish projects and they turn in half-done stuff. So there's a lot to it. And, you know, break it down step by step by step, and we'll tackle one little problem at a time, for sure. And if you get stuck on something, let me know. Just let me know how I can help. I don't see anybody there. Let's see if anybody's here. Let's see if there's anybody we can raid for fun. Oh, Bother Zombo, we keep raiding him all the time. Let's see who's around. Ooh, we got art, if someone wants to go watch an art stream. We got ceramics, if someone wants to go watch some ceramics. Got a couple fun places. Or the St. Louis Chess Club, if anyone wants to watch chess. Over to the St. Louis Chess Club. Anyone have a preference? Ooh, Rob's on. Oh no, he's off though. He's like always live. It's weird. No preferences? We can just end then, if no one has any preferences. Alright, we'll just end it then. You folks take care. Let me know how I can help. See you around, everybody.